Hello, everybody. My name is Karen, and welcome to the Great Lakes Science Center. I am coming to you from our newly renovated PPG Labs. It looks great in here. Thank you, PPG. So today, I'm going to show you an easy experiment that you can do at home with things that you most likely already have in your house. But before we begin, why STEM? Why STEM for kids? So STEM, as you know, is science, technology, engineering, and math. So of course we get the science and math skills that we need for school, but also doing these fun activities like how I'm going to show you is a great way to learn other skills that are so necessary in life, no matter what career we go into. We have creativity. We urge you to be creative in STEM. Think outside of the box, be innovative, right? Think of new ideas for new ways to do things. And also problem identification and problem solving. Many times we know that problem solving is such a great skill needed for, once again, any type of career. But how do we know what that problem is? We have careers such as engineering now looking for those problem identifiers, people that can figure out what that problem is in order that we can solve it. We have persistence and perseverance. STEM activities help us learn that we may not get that right answer on the first try. We may have to try over and over and over again to get the result that we need, and that's okay. Here, failure is okay as long as we are learning what not to do from it, as long as we're not trying the same thing over and over. Persistence and perseverance, once again, are crucial in any job field that you go into. So now that we know why STEM activities can help us with any career that we may go into in our life, let me go ahead and show you a quick and easy activity that I love. So today we are going to be making a lava lamp. Now, when I was a kid, I had a lava lamp in my room. I believe it was purple, and I loved it. It's very mesmerizing. Just watch it over and over and over. So how does it work, and why does it work? And I'm going to show you that right now. The things that we need are a clear container. I'm using my beautiful big old flask right here just because it makes me easier to show you what's going on. You can use a water bottle, a 2-liter pop bottle, a jar, any type of clear container of any size is perfectly fine. Use what you have at home. Next, I have some vegetable oil. Any type of cooking oil is fine. And you can even use baby oil. Baby oil is awesome too because it's clear, so it might give you a different look. Try out what you have. Make sure whatever oil you have stays liquid at room temperature because we're going to be talking about liquids today, and we do need it in liquid form. Okay, so the first thing we're going to do is pour some of our oil into our container. And honestly, I urge you to try to pour different amounts and test it out. Are the reactions the same if you use less oil or more oil? And I'm going to use a lot of oil because I have a big container here for you. So I'm going to go ahead and pour in a good, decent amount. There we go. Next, I am going to add water. So we're going to start learning about density. We may have heard about density before. Density is pretty much how many atoms and molecules are packed into an object. Density is very closely tied to weight because, of course, the more stuff you have in something, usually the heavier it is. So we normally think of density with solid objects, right? We have a bowling ball and a playground ball. Which one is going to be more dense? Bowling ball is filled with stuff that's pretty heavy. There's a lot of stuff in that bowling ball. A playground ball is usually hollow, filled with air. It's not as much stuff in there. And so our bowling ball is more dense. Well, we can also use density with liquids. So we have oil and water here, and many of you have seen this while cooking, right? You'll see them separate. Well, that's because they have different densities. So can we guess which one is more dense? Let's see. I'm going to go ahead and pour my water on top of the oil. Let's see which one goes to the bottom, which is going to be more dense, and then we can see which one goes to the top, which is less dense. And as you pour it in, it's okay for it to create these really cool bubbles. Those will help us with our lava lamp. And that's about enough. Okay, so right away, I'm going to look at this, and I see that the water sank right down to the bottom. And we can see this clear layer underneath here. That's all the water going right down to the bottom. So once again, water is denser than oil, or oil is floating to the top. That's what's going to help us with our lava lamp. And now, so that we can see this better, and because it makes a really cool effect with the lava lamp, I'm going to get some food coloring. I'm using red just because it's really easy for you to see. And I do love red. You can use whatever color you want. You can use as much or as little as you want. Be creative with it. Combine colors and see what effects you get. This is one of my favorite parts of this experiment. As I'm dropping the food coloring in, you can see that even the food coloring has a different density than the oil and the water. And these little spheres of color are kind of floating to the bottom. So what does that tell you about density of the food coloring? Now, here comes my magic ingredient. Alka-Seltzer tablets. Usually we think of Alka-Seltzer tablets for our tummies when our tummies are upset. Well, Alka-Seltzer is going to help us create our lava lamp effect here. What it does is when combined with water, it produces carbon dioxide gas. Well, as we know, gases like to escape. Gases like to go up into the air and dissipate. They just want to spread out. So we're going to put this in, have it make carbon dioxide in the water. You're going to see it start bubbling up. And let's see what happens with the coloring and the oils and everything else that's in there. Now I'm going to be using 2 full Alka-Seltzer tabs because I have so much liquid in here. Experiment. You may want to start, if you have a small container, which is totally okay, you may want to start with just a piece of Alka-Seltzer. Here goes 1. Oh, and we can already start seeing it bubbling. Oh, this one broke. That's okay. We're going to go ahead and put that in there anyway. Awesome. Do you see what's going on? It is creating these big bubbles and these little bubbles and all these bubbles of different sizes. And what it's doing is those Alka-Seltzer tabs sunk to the bottom, and now it's creating that gas, and that gas is carrying these waters and these bubbles up to the top because the gas wants to rise up to the top of the water. As soon as these bubbles of gas hit the top, they're breaking open, the gas is disappearing and dissipating out into the air, and then the bubble floats back down because it's not being held up by that gas, which is lighter density. And now the bubbles are floating back down because they are denser than the oil and they're going back to the bottom. And this process is going to repeat and repeat and repeat itself as long as you have that carbon dioxide forming in here. So I can reuse this. You can even sit this aside for a couple of days. You'll see that the oil and the water will separate again because of that density. And then you can start it up again just by adding some more Alka-Seltzer tabs. So that was a lot of fun. I hope you will have a lot of fun making your own lava lamp at home. Please remember to share it out with us. Show us what you're doing. #StayCuriousCLE. And once again, as always, stay safe, Cleveland. Stay curious, and we hope to see you again soon at the Great Lakes Science Center. Bye.